So today our group will do for the latest theme design Library of Engineering Faculty UPM. So before I start, I will introduce my group members. So I am Siti Nursyahirah 174774. This is Mohamad Hilmi. That one is Mohamad IkhwanBin. This one is Ong Wee Chiek. So we'll go to my introduction. So, introduction. Lighting system defined as the deliberate use of light to achieve practical or aesthetic effect. So we have two types of lighting. One is natural, the other one is artificial lighting. So the importance of lighting system design is to ensure the safety of people in interior. And the second one is to facilitate the performance of visual tasks, to aid the creation of an appropriate visual environment. This lighting system design is seen as one of power saving solution. And when we save power, we also reduce global warming effect as it affect the heat produced. Then, of course, when we do power saving, we will reduce the electric bills. So, place that we choose is Library of Faculty in Engineering. So why we choose our library? Because the location is here. So the cost to do this study is reduced because of that. And libraries play a very important role in our faculty. And we are very curious on the efficiency of lighting system design in our engineering faculty. So this advantage of current lighting system design is they has excessive number of luminaire and lamp use, and the second one it consumes very high power when they produce very less lux, and the last one is the estimation of electric bills per annum is too high. So I pause reading.
Assalamualaikum warahmatullahi wabarakatuh, and good morning to everyone. My name is Hilmi. Thank you, Sarah. I will continue for methodology section. First, for this methodology, we can classify into 4 sections, which are participant, sample, procedure, and also method. First, for participant, first of all, for this project, we involve, of our group members, which are from Faculty of Engineering, University of Malaysia, taking courses lighting actually basically we enrolled in course of power generation and utilization. The title of this assignment is lighting. Okay, next, during conducting this project, several parties was involved indirectly. First is our lecturer, Dr. Nafis, as he guide us to do this project, and then the library staff, and also the development and maintenance department, where we try to get the layout of the library. And then for the second, which is sample, we take it from Library of Engineering Faculty, University of Malaysia, where we use the layout that we get from the development team to get the overall view of our project, and then we try to calculate manually the existing system, which we find it was 112 luminaire with 2 lamps in each luminaire. The next is for procedure. We investigate the existing system as a guide for us to design the new system. We use the layout to get the overall view, and then we will compare this layout with our new design. And then for luminaire, we use it as a guide also for a calculation to get the how much the luminaire required that will be presented by Ong after this. And for the method, two methods have been used in order to design the new lighting system. First is, as I mentioned earlier, we use a manual calculation, and also we use Dialux Evo 6.1 software as the medium for us to design the layout for the new system. Okay, next, Ong will continue this presentation.
Okay, so now I will present about the lighting system design. Okay, first of all, I will talk about the luminaire design. The luminaire design chosen in this lighting system. Okay, the name of this luminaire is Regions AS N24607912 Illusion LED TW. Okay, these are the characteristics of this luminaire. It has a luminous flux of 4,451 lumens, and then the power for each luminaire is 45 watt. It has tunable white feature, and which the temperature can be tuned from 2,700 to 6,500 Kelvin. And then as the LED, it has a low energy consumption, and besides that, it is also easy to install. And another special feature about this luminaire is that it has a centrally mounted high-performance microprism lens that can improve the efficiency by increase the emission of downward light. In this microprism lens, there are actually mirrors inside the lens that can adjust the angle of the light, which to provide a maximum downward emission. Okay, first, the maintenance factor. Okay, as you can see in the table, the lamp luminance maintenance factor and the lamp survival factor, these are provided by the manufacturer, which is the Regions Lighting. Okay, so as you can get from the data sheet, this luminaire that we choose is a L7B10 at 50,000 hour rating. Okay, it means that the luminaire will produce 70% of the initial light output after 50,000 hours, and the B10 means 10% of tested product fail within 50,000 hours. Okay. So based on this rating, we managed to find the maintenance factor from the table. And the expected operating hours for this luminaire in this library is 30,000 hours. Okay, so we can find that the lamp luminance maintenance factor is 0.84 and the lamp survival factor is 1. Okay, next. Okay, next we find the room surface maintenance factor based on the 70, 50, 20 reflectance. Okay. And we assume that the condition of the library is very clean, and due to the difficulty of to do the cleaning work, okay, we assume a 3 years of room cleaning interval, and then based on this, we managed to get the room surface maintenance factor, which is 0.97. In this case, the luminaire we chosen is the direct luminaire. Okay. And the light survival factor is 1 because we highly recommend spot replacement, which means that the broken luminaire should be replaced immediately after it is found to be faulty. Okay. So based on the figures we get just now, we can get the overall maintenance factor, which is 0.8148. Okay, next we'll proceed to the utilization factor. Okay, basically we divide the library into 2 sections, which are rectangular and with dimensions of 30 meter times 70 meter, which is the bookshelf area, and another area is 30 meter times 21.5 meter, which is the study area. Okay, and the height of library we measure is 77 meter, and the working plane, which is the table at the study area is 0.8 meter. With that, we can find the difference between the height and the roof plane, which is 6.2 meter. Hence, we can get the room index, okay, for each area, and then we find the average of the room index for these two areas, which is 1.553, and then we'll get the utilization factor from the chart here, which is 0.76. Okay, number of luminaires. Okay, this is how we get the number of luminaires. The standard weighted illuminance of the library is 300. So to get the number of luminaires, we use the lumen method formula. Okay, as you can see here, the 300 is the standard maintenance luminance factor, and the 500.5 is the area of the total area of the two sections just now, and the 4,251 is the luminance, that's the lumens of each luminaire, and with the maintenance factor and utilization factor, we managed to get the number of luminaires required is 54. Okay, with that, we divide the 54 between the area A and area B just now, and then we get 34 for the first area and 30 for the second area. Okay, this is the lighting design in area A and area B with the width and the length and the spacing between the rows and the spacing in row. Okay. This is the floor plan view of the library lighting system design. We designed the Dilux Evo 6.1 software based on the design we calculated just now. Okay, just put it inside the software. Okay, this is the 3D rendering of library lighting system design. We, as you can see, there are luminaires inserted inside, and then the bookshelf and the study area here, and these are the windows in the library. Okay, and we managed to simulate the luminance on the work plane with light received from outside the building and without light received from outside of the building. There is a big difference here because in library, during the day there are many lights coming from outside because there are many windows in the library. So as you can see with the light from outside, then the illuminance is 2,866. This is way over too high. That's why we can see that the library is using the curtains to hide to prevent the sunlight from outside. Okay, and without the sunlight, the illuminance is actually 500. Okay. And next, Nursyahirah will present about the power consumption cost.
Okay, so from this, this is the table for it. So the table is about the total number of luminaires left or per luminaire, power rated and total demand of existing and design lighting system. So for existing, like we said, we have 112 luminaire in total. For proposed, we only have 54, so it's totally quite large number. We reduce it. And then for existing, we have 2 tubes of fluorescent lamp for each luminaire. And for the proposed one, we only have 4 LED per luminaire. So for each end, the power rated is 36 watt for the fluorescent lamp, and for the LED is 11.25 watt. And for the total one is 72 watt and 45 watt for LED. For the total demand that they have is for the fluorescent is 8.064 kilowatt and the LED 2.7 kilowatt. Okay, so this is how I calculate the total demand. So for total demand for existing system, by calculating the power rated for each capital N, we will get times with the total luminaire, we have the power. Same one for the total demand. So the power rated is 45 watt. So we times with 54 luminaire, we will have 2.7 kilowatt. Okay. The second table is about comparison in total power consumption, maximum demand, and calculated electric bills between two systems. So for the electric bill, we use the auto generated from tnb.com.my, and before we can use that auto generated electric bill calculation. So we need to find these two: total power consumption per annum and the maximum demand per annum. So for existing, we have calculated, we got 27.42 megawatt hour, while the proposed one is only 7.216 megawatt hour. So it's quite different. The difference is like 20 megawatt hour. So for the maximum demand is 9.85 kilowatt for existing, and the proposed one is only 2.59 kilowatt. And in terms of electric bill, the result is for existing, it costs about 10,482 ringgit and 1 cent, while the proposed one is 2,758 ringgit 68 cent. So for the commercial one, we must include GST. So that's why this price is already included with GST. So next, this is how the formula used for the total power consumption. So we have the total lamp times the total luminaire times the power consumption per lamp times the total operating hour. That one is only for the lighting. And the next one is total number of air conditioner times the power consumption per air conditioner times total operating hour for the air conditioner. And next is total number of socket times the power consumption per socket times total operating power. So that one is the socket. And for the maximum demand compared to total power consumption, we just for the total power consumption for each, we need to times with the operating hour. But for maximum demand, it's only between the total number of electrical appliance times with their power consumption. Okay, this is auto-generated from www.tnb.com.my. So what we need to do, we just need to choose our category. So for the library, we choose for commercial. So the tariff code is C1 because it's a medium voltage. It generates more than 1 mega. So then for we just insert our total consumption and maximum demand. Then we click the calculate bill. We will get the current bill. Then we will get for the 6% GST. For here, the current bill is 9,888 ringgit 69 cents, but the GST is 593 ringgit 32 cents. That's why it becomes 10,482 ringgit 1 cent. So from here, you can know for the current month consumption and everything. So this one is for existing. This one is for the proposed. So as you can see, actually we reduced for about 73% of electric bill and the power consumption. So okay. So I'm sorry, I forgot about the cost. So this is the cost for installation cost. So for each 36 watt fluorescent lamp, we use Philips because the library use Philips. The 36 watt fluorescent lamps cost 6 ringgit and 40 cents because fluorescent lamp usually cheaper than LED. So therefore LED is 25 ringgit and 90 cents. But although the cost is very high for installation, we can recover it with the reduce in electric bills.
Now we continue about the compliance to stated task. Second, influence the environment surrounding. And for the last, it ensures safety and health of the people in the interior. Like Sierra said earlier, this is the basic lighting design that we need considered in our design system. Okay, next is the factors that determine good functional lighting design. First is amount of light energy available for specific visual tasks. For example, the source that supply the lighting for our interior, for our space, and then for the second, direction of the light relative to the eye, and then for this second factors, it consists of direct and indirect lighting. Which direct lighting is, for example, in our daily life, from the sun we get direct the light, and then for indirect, it's the light that have been reflect from the many factors such as the floor, ceiling, and then the third is the surface reflectors. Also plays a factor in determining the good functional lighting design. And for the last, the brightness of object around the last object. Okay, light source. For in this assignment, the light source has luminous intensity. The proposed lighting source is illusion LED tunable white. And for the existing system, common light source used nowadays are fluorescent. And then for the third, light level or illuminance actually is the amount of light measured in a plane surface. The unit of measurement is lux. And for the standard that we use as the guide before we design this lighting system, the minimum average illuminance in library, which we highlight the reading area, should be 300 lux with a high uniformity. This table actually shows the standard maintenance illuminance, characteristic activities, and also representative activities. Okay, for standard maintenance illuminance, as I mentioned earlier, the minimum standard for the library illuminance is 300, and the characteristic activities is the interiors occupied for long periods or when visual tasks are moderately used. And for the representative activities, libraries, sports and assembly halls, teaching space, lecture, trades, and also banking. Okay, the implementation of the latest technology on lighting. IkhwanBin will continue this presentation.
Okay, thank you, Hilmi. Okay, now I will continue our presentation about the implementation of the latest technology on lighting. So here we propose the technology that can be used to the lighting design is occupancy sensor and also white tunable LED. Okay, so occupancy sensor. So occupancy sensor is a control device that can detect the people or other motion, and it will turn on and also turn off by automatically by using some other technologies such as infrared, ultrasonic, microwave, and other sensor technology. So the occupancy sensor have frequently been promoted as the one most cost-effective technology available for modifying commercial lighting system. So because okay, next. Okay, this is the three type sensor that commonly used in the commercial building. So the first one is basic infrared motion sensor or PIR sensor, ultrasonic motion detection, dual tech motion detection. Okay, next. So this is the PIR motion detection. So it will detect a major motion. So the basic operation for the PIR sensor, whenever the sensor detect the heat, it will turn on or turn system. So in our case, we use for the lighting. So the advantage for BIR sensor of detection is the price is cheap, small size, and also the sensor has low power requirement. So the limitation of the sensor is the coverage is directional and limited to the line of sight. So we move to the next point, which is ultrasonic motion detection. So ultrasonic technology in occupancy sensor is excellent for minor motion detection. So ultrasonic work by emitting a pulse into a receiving and it will bounce back. So it can know the range of the object. So the main advantage is it can see around the object, thus detect minor movement. So the limitation is it is required a specific location, higher power consumption, and also prone to false contribute due to its sensitivity. Okay, dual track motion is combination between ultrasonic and BIR sensor. So this is for optimization of the detection. So the advantage is to detect both major and minor movement. And the limitation is of course the price is expensive. So this is the recommendation for large open space. The dual track motion will be used, and for medium and smaller space, BIR more suitable to use. So the tunable white LED. So it has two control postcode code. So the postcode code is usually the method to combine a color, and it is commonly used. So there are two, which is warm white color, which is range 2700 Kelvin, and also cool white color, usually 500 Kelvin, and to the 6500 Kelvin. So the application can be used for a wide range of application. So it will provide cooling or warming depending on the situation and weather. So it will stimulate our mood and also increase the productivity. So the control number one actually is a very crucial part. So it requires power of the LED driver and for the control signal. So it needs to have separate power. So the commonly used are 10 to 0 volt, DMX and DLI. So this is the configuration of the controller. This is for DMX controller configuration. DMX controller, and also there has splitter. Okay, this is DLI controller, and also the DMX controller with the DMX and DLI converter. So the advantage is to change the color of the light according to the surrounding. So it will increase productivity, provide comfortable atmosphere. So it is flexible depending on surrounding condition, and lower energy consumption. So the potential issue of the tunable LED is of course complex wiring, and the efficiency of white LED is higher than full color TV system, but it still lower than the fixed white LED. So the conclusion, the design step of the lighting model to calculate number of luminaire. So the method that we use, as mentioned before, which is using a manual calculation and dial-up equals 3.1. So from the design lightning system, we managed to get low power consumption and maximum demand, and as well as the reducing the cost of TNB bill. So the number of luminaire also will decrease. Okay, so the power consumption and maximum demand also can be reduced. So as the Nursyahirah told before, the TNB bill also reduced from 10,482.1 cent and to 2,758.60 ringgit, including 6% GST. Okay, this is our reference, and that's all from us. Thank you.